In this video, I will explain how to solve for the marginal rate of technical substitution. So let's jump right into an example. This says, suppose a production function is given by q equals 500L to the 0.6 times k to the 0.8. Find the marginal rate of technical substitution, then evaluate at L equals 10, so labor equals 10, and k equals 15, capital equals 15. So when we're given a production function like this, the way that we find the marginal rate of technical substitution, I'll abbreviate it as MRTS, we use the following formula. We take the marginal product of labor and we divide that by the marginal product of capital. Now, the marginal product of labor is just the derivative of the production function with respect to labor, or L, and the marginal product of capital is just the derivative of the production function with respect to capital. So let's go ahead and start solving for some of these values. So we can say the marginal product of labor, so we said that's the derivative of the production function with respect to labor, L. So if we take the derivative of this function with respect to L, what we would do is take this 0.6, so the exponent, and multiply it by the coefficient. So 0.6 times 500, that turns out to be 300. And then we have L, and then we have to reduce this exponent by 1. So 0.6 minus 1, that's negative 0.4. And because we're multiplying by k to the 0.8, we have to include that as well. So k to the 0.8. Then to find the marginal product of capital, we're going to take the derivative of this function with respect to k. So to do that, we would take the 0.8 and multiply it by 500. So that turns out to be 400. So we'll say 400. And then we have to multiply by L to the 0.6. So this quantity doesn't change at all because remember, we're taking the derivative only with respect to capital. And then we have to reduce this exponent by 1. So 0.8 minus 1, that's negative 0.2. So k to the negative 0.2. So we have our marginal product of labor and our marginal product of capital. To find the marginal rate of technical substitution, we're just going to take the ratio of these two values. So let's go ahead and write that. So here's what that looks like. Now we can simplify a little bit. 300 divided by 400, that's the same as 3 divided by 4. So we'll have 3 divided by 4. Now notice that we have a negative exponent on labor right here in the numerator. To make that positive, we can just move it down to the denominator. So what we'll have in the denominator is L to the 0.6 times L to the 0.4, which is just L to the 1, or just L. And similarly, to make this negative exponent positive, we can move it to the numerator. So in the numerator, we'll have k to the 0.8 times k to the positive 0.2, which is just k to the 1. So our marginal rate of technical substitution comes out to 3k divided by 4L. Now we are also asked to evaluate this at the value L equals 10 and k equals 15. So all we have to do is just plug in those values for L and k right here. So let's go ahead and write that down. So at a value of L equals 10 and k equals 15, the marginal rate of technical substitution is going to be 3 times, so for k we're plugging in a 15. So 3 times 15 over 4 times, for L we're plugging in a 10. So we get 3 times 15, that's 45, divided by 4 times 10 is 40, and 45 divided by 40, that comes out to 1.125. So at these specific values for labor and capital, our marginal rate of technical substitution is 1.125. Now, what does that actually mean? So here's what it means. When labor is increased by 1 unit, capital can be decreased by 1.125 units and output will remain constant. And that's the entire definition of marginal rate of technical substitution. When we increase one of our inputs by 1 unit, how much can we decrease the other input by and still maintain the same level of output? So that is how you can calculate the marginal rate of technical substitution when you are given a production function.